In this video, I'll talk about the problem in your packet. It's actually an example, and it's worked out almost entirely in the packet, but here I've presented it on the problem-solving template. And so we see that we're asked for velocity. Velocity is a vector, and vectors have magnitude and direction. So even though it seems simple, they're only asking us for the velocity, it's actually a fairly challenging problem, especially when you're first getting used to this. So you're given that it's 44.1 meters per second. That's the initial velocity. First thing is, you don't want to use that in any of the equations on your equation sheet because V0 does not show up in any of those equations. What you need to do is figure out, using trigonometry, what V0x and V0y are. Once you know what those are, then you can use V0x in equations in the x direction, and you can use V0y in equations in the y direction. So here our plan is simply to use this one equation. We know this and this and this, and we can go ahead and solve. Now, here we solved for the magnitude, 44.1 meters per second times sine of 55 degrees. We know it's downward, and we picked up to be our positive y direction, so that means we need to put a negative sign right here. We get Vy equals negative 65.5. And a lot of students will stop here. They say, hey, I solved for the final velocity. Well, what you solve for here is the final velocity in the vertical direction. But that's not the final velocity. Okay? That's not the velocity 3 seconds later. That's the vertical velocity 3 seconds later. So to find what the velocity is, that's v, 3 seconds later, we need to consider that it's still moving in the x direction, and now it's moving faster in the y direction. Okay? This down here is called a final velocity vector diagram. Just like up here, we drew an initial velocity vector diagram. Shows V0x, V0y, V0, and the angle. Here, we're showing Vx, Vy, the angle, and what V is. So these are the two things we need to find. So we can find V by the Pythagorean theorem, and forgot to put a square root sign there. So V ends up being 70.2 meters per second. That answer makes sense. It's larger than 44.1. Also, it's larger than either of these components. Sometimes students make mistakes with negative signs, entering them into their calculator, not using parentheses correctly. But I don't even put negative signs in when I'm doing the Pythagorean theorem. I only take the magnitudes because that's all that's important. When I'm doing my tangent and my Pythagorean theorem, I only need the magnitudes. I already know which direction it is. It's going to be going diagonally down to the right. That's the general direction. Specifically, I do need to calculate it. It comes out to 68.9 degrees. Which brings me to another point. We're not going to put a negative sign here. Because what would that negative sign mean? Does that mean it's down and to the right? So one positive and one negative direction? Or what about left and up? That's also one negative direction and one positive direction. What about left and down? That's two negative directions, so I put a negative sign. No, the negative sign does not tell me what direction V is. V is at an angle, and a simple plus or minus sign is not enough to tell me what direction V is. So no negative signs go on V or V0. The negative signs make sense for V0x or V0y or Vx or Vy. Okay, so for all of these, I'll circle them here. For all of these, a plus or a minus sign makes sense, but not for V, not for V0. Okay, so we have completed the solution. The sign is correct. These are just both magnitudes. Correct units, yes, degrees and meters per second. And we talked about the magnitude of the speed. The angle, it also makes sense that it's greater greater than 55 degrees. As it falls, the further it goes, the greater this angle is going to be. make sure you take some time to read through on the next page of your packet. This is what I was just talking about. A positive or negative sign is a clear way to tell the direction for these 4 vectors, but it's not a clear way to show the direction for these vectors. So if you're asked for the speed in a problem, all you have to do is find v. Okay, v is the magnitude of the velocity. If the problem asks you for velocity, like the one we were just doing, in that case you have to find the speed. You need to draw the velocity vector diagram, and it tells you in detail here how to do that, and I have an example of that on the last page. And you also need to include the angle. So if it asks for velocity, there's 3 components: speed, the velocity vector diagram, and the calculated angle. So when you get to those problems where it asks you for velocity, now you can refer back to this.